Let's finish up section 2. Yesterday, we looked at angles that were in the first quadrant. Okay, we did the 30, the 45, and the 60. Okay, today we're going to look at multiples of those angles. Okay, so what that basically means is we could be in quadrants 2, 3, or 4. Okay, as long as you understand the basic idea of what we did yesterday, today is a very, very small extension, very small. We're still going to use the 30, 60, 90 and the 45, 45, 90. So we're still going to see numbers like 1/2 root 3 over 2 and root 2 over 2 and root 2 over 2. Except it's going to be in different quadrants. All right, so we'll just start off with an example. There's really nothing new in terms of notes I need to explain to you. You already know what you need to do this. We're just going to apply it a little differently. All right, so let's look at the 6 trig functions for 135. Every angle that I give you that we're going to do on this circle, it has to be either a multiple of 30 or a multiple of 45. If it's not, we can't do it on this circle. Okay, let's look at 135. Is that a multiple of 30 or a multiple of 45? Yep.
45.
That's a multiple of 45. Okay, it's 45 times 3. So when we do this problem, it's going to have something to do with the 45, 45, 90 triangle. Okay, let's see if we can sketch it. Okay, 0. There's 90. Okay, where would 135 be? Tyler?
Between 180 and 90.
Okay, can you be a little bit more specific? Like,
Right in the middle.
yeah, exactly in the middle. Okay, 135 is exactly halfway between 90 and 180. So put your point. Okay, I'm going to make my triangle. Okay, and earlier we said that this is the 45, 45, 90 triangle. Okay, if you weren't sure, okay, you're like, I'm not sure which one it is. Look at the difference between 90 and 135. What do you add to 90 to get to 135?
45.
Yeah, you add 45. So this part on the outside is 45. So how much would this part on the inside be?
Also 45.
Yeah, it would also be 45. Because together the quadrant makes a 90. So if that part's 45 on the outside, that part's 45 on the inside. Okay. And then once you know 2 out of 3 of your angles in a triangle, you could just add them up and subtract from 180. All right. Next part. Okay, we got to remember how long the sides are in a 45, 45, 90. Okay. Anybody remember what they're the same? We just did them in the homework. George? Yep. Square root 2 over 2. And the height? Same. Square root 2 over 2. All right, so now our coordinate for 135 is going to be very similar to 45. The only difference is instead of going right and then up, positive, positive, we're going left and then up. All right, so we just got to be careful with our signs. All right, so Cooper, you think you could give me the coordinate?
Negative square root 2 over 2, square root 2 over 2.
Perfect. And that's the only difference today. Okay? The only difference is you might have a negative in the first one, negative in the second, or negative in both. But the numbers themselves are the same. It's just a negative. Okay, and we'll do the same thing. This is the only problem that we're going to go through all 6. After this, we're just going to go through 1. Okay, one of these per problem. All right, so Rachel, my sign, which letter is that?
Letter?
Yeah.
Oh, Y.
Yep, that's my y value, which in this case is root 2 over 2. Okay, Tyler, my cosine?
Negative 2 over 2. Well, negative square root 2 over 2.
Yep, negative root 2 over 2. Okay, my tangent, that's what I get when I divide y by x. You're dividing two things that are the same, except for the sign. Right, so Florencia, what would I get there? Dividing two things that are the same, except one's positive, one's negative.
Negative square root of 2.
Well, think about, what if you did this? What would that be?
-1.
Yeah, -1. This is also -1. Because we're dividing two things that are the same except for the sign. Okay, now my cosecant. Amber, what do we get when we flip that?
The square root of 2. Oh, the answer?
That's it, don't say anything else, you're right. Square root of 2. Any questions on how we flip that and get the root to the top? No? Okay. Brianna, how about my secant?
Is it negative square root of 2?
Yeah, it's just negative square root 2. Okay, sine and cosine are almost the same, except one's positive, one's negative. So cosecant and secant are going to be almost the same, except one's positive, one's negative. Okay, and my last one, Hunter. What would my cotangent be?
-1.
Yep, when you flip -1, it stays the same. Right, so there's all 6 trig functions for 135. Any questions on that one? All right, let's try it for pi over 4. Okay, some of these problems will review what we did yesterday as well. Okay. Okay, Kobe, what would that be in degrees, pi over 4? That's a common one we use a lot.
It's 60.
Right? How would you, how do you convert it? What do you multiply by? 180 over pi. So 180 divided by 4. So basically take half of 180 and then take half of it again. 45. All right. If you already know your coordinate for a 45, I wouldn't even bother with the sketch. Okay, you don't need it. But if you're not sure, you can always make your sketch. Okay, from the last problem, hopefully you remember the sides, both root 2 over 2. And since we sketched it, now we can figure out we're in quadrant 1. That's positive, positive. So root 2 over 2, root 2 over 2. That's my coordinate for 45. All right, last thing I need is the cosecant. Yep.
Square root of 2?
Yeah, which one did you flip, x or y?
Y.
Yeah, even though they're the same here, you want make sure you do know which one to flip, because most of the time they are different. Flip that, you get square root of 2. Okay, this is how the test will be set up. One question per problem. Give me the coordinate, give me the answer. All right, let's try sine 225. Okay, Tommy, where's 225 going to be?
Halfway between it's somewhere between 180 and 270.
So there's 180.
Halfway.
You think it's exactly halfway?
Or it's like either halfway or a third of the way.
All right. Well, what would you add to 180 to get to 225?
So halfway.
Yeah, so it is halfway. Okay, I can already tell what kind of triangle this is before I even sketch it. Okay, 225 is not a multiple of 30. It can't be. If a number ends in 5, it's not a multiple of 30. It's got to be a multiple of 45. All right. So because it's a multiple of 45, I already know the two side lengths. That's the root 2 over 2, root 2 over 2. Okay, the only reason you might want to sketch is if you're not sure if they're negative or positive. All right, so that's root 2 over 2, root 2 over 2. And there's my triangle. All right. Somebody give me my coordinate for 225. Yeah, go ahead.
Negative square root of 2 over 2, and then it's negative square root of 2 over 2.
Yeah, they're both negative. Okay, now remember, that's not the final answer. That's just going to help us to find what they want. They want the sign. Okay, so Emily, what's the sign of 225?
Negative square root of 2 over 2.
Yeah, and which one did you pick, X or Y? Yep, she picked the Y, perfect. Okay, any questions on that one? All right, let you guys try that one. Okay, try to find the cosine of 7 pi over 4. All right, when we convert 7 pi over 4 to degrees, anybody get that? 45? Anybody else get 45? It is going to be a multiple of 45, but I think it's in a different quadrant. 315, yeah. Let's just make sure we got that. It's 180. So we got 7 times 180 divided by 4.
Oh, I reduced that 4. Yeah, that's why I kept reducing. I did 180 divided by 4, reduced them.
And then times 7?
Simplified them. Yeah.
Yeah, that's the same thing.
I got 45.
Yep, so you did 180 divided by 4. That's 45, and then times the 7 on top.
Oh.
So 45 times 7 would be 315. You can do it that way, though. Yep. So cosine 315. Okay, so when I see a number ending in a 5, what kind of multiple am I thinking? Multiple of what?
45.
45. So we're thinking root 2 over 2s. It's just a question, are they both positive, negative, or one of each? Well, here's 270. Here's 0. What's 0 the same as?
360.
It's the same as 360. Might be helpful to think of it that way. 315, it's exactly halfway between 270 and 360. Okay, make your triangle. Write the coordinate. Right, so I've got root 2 over 2 and root 2 over 2. Just be careful because we're in the fourth quadrant. One of those should be negative. So Eddie, what's my coordinate for 315?
Should be it should be root 2 over 2 negative root 2 over 2.
Yep, perfect. Good job. Okay, now cosine. Okay, that's one of the real easy ones. You just have to pick one of these numbers. Just gotta make sure we pick the right one. Okay, cosine is which letter?
Root 2 over 2.
Yep, it's the x, which Eddie just said, root 2 over 2. Good. Okay, so there's basically 4 different spots the 45 degree angle can be in. Okay, there's the 315, just the basic 45, 135, and 225. And for each one of those spots, I could ask you for one of 6 trig functions. Could ask you for the cosine, the tangent, sine, okay, whatever one. But each problem only asks you for one thing. Okay. Questions on the 45s? Okay, so that's it for the 45s. Okay, tangent of 120. Just by looking at that number quick, how do you know it's not a multiple of 45? Yeah, it ends in a 0. All right, so the ones we're talking about for multiples of 30 and 60, those are going to end in a 0. Okay. All right, so we're looking for 120. So now, when we sketch it, we're not exactly halfway between two numbers. We're closer to one of them. Okay, which one am I closer to here? Closer to 90? Closer to 180? We're closer to 90. Okay, we're only 30 degrees past it. Okay, so put it about right there. Right, so that's 120. and make your triangle. Now, what's important with the 30, 60, 90 is you've got two different angles. It's not like the 45, 45 where they're the same. You've got to put the 30 and the 60 in the right spots. Okay. How about Aaron? What's the difference between 90 and 120? 30, yeah. All right, so we have a difference of 30 degrees in this part right here. So how about this part down here? How much would that be? If this part's 30.
60.
Yeah, this part would have to be 60. Because together they make a quadrant, which is 90. So this is 30, that's 60. And where does that mean my 30 degree is in this triangle? Where's that angle? George? That's at the top. That's my 30. All right, what are the two numbers that are involved here? Okay, it's not root 2 over 2. That's the 45, 45, 90. What's one of them? Yeah.
Square root 3 over 2.
Yep, so we got square root 3 over 2 and 1/2. Okay, you just got to figure out which one goes where. Okay, my trick, smaller angle, always goes across from the smaller side. So which side is smaller, 1/2 or root 3 over 2? 1/2. If you type that in on a calculator, that's 0.5. Root 3 over 2 is about 0.87. It's bigger. Okay, so 1/2 goes there. Bigger side across from the bigger angle. Okay, now we can write our coordinate. Okay, Amber, what's my coordinate for 120? Yeah. Perfect. Negative 1/2 because you're going left. Square root 3 over 2 because you're going up. Okay, now they want the tangent. Okay, so Jamie, to get my tangent, how do I do that?
You would divide 3, or the square root of 3 over 2 divided by negative 1/2.
Yep. Great. So divide them. Anytime your denominators are the same, you can cross them out. And Jacob, what am I left with my final answer?
Negative square root of 3.
Yeah, I'm just left with square root of 3 divided by negative 1. Negative square root 3. Okay, questions on that? All right. Okay, secant of 690. Okay, we're not going to go through every single trig function for every single angle that's a multiple of 30, but we'll try a couple in each quadrant, and I've got one extra one at the end. If we don't need to do it, we can just go to the last thing after. Okay, but if people want to practice a few more, we can do that. All right, 690. Okay, kind of big. You've seen this before. Amanda, what can I do to make that smaller?
Minus 360.
Yep. So that's 330. Right, so Megan, where's 330 on this circle? Yeah, it's going to be in the fourth quadrant. Okay, so here's 270. Here's 360. Are we closer to 270? Closer to 360?
Closer to 360.
Yeah, we're almost all the way around. Okay, we're just 30 degrees shy of going all the way around. All right, so make your triangle. And if you draw this reasonably well, you should be able to tell which side is the long side and which side is the short side. Okay. This is my short side. That's my long side. But if you can't tell from your sketch, look at it this way. Okay, here's 330. Oops. 330. Okay, you're 30 degrees before 360. So this part right here, that's my 30. Okay, that's the 30. That's my 90. That's my 60. Okay, so my coordinate, well, Chelsea, what would be my coordinate for 330? Yep. Good. So positive square root 3 over 2, negative 1/2. Now they want the secant. That's when you take your x and flip it. Okay. And Amanda, do you remember what you get when you flip square root 3 over 2?
Me or
Yeah.
square root 3 over 2?
And we're going to flip it.
2 over square root 3.
All right, so we flip it. And what will that simplify to when you get that square root out of there?
2 square roots of 3 over 3.
Perfect. 2 square root 3 over 3. Good job. Okay. Questions on that one? All right. This was going to be my last one for this type of problem. Does anybody want to see one more, or you think we're good? We're good? Okay, if you were going to do it, my first step would be change it to degrees. Probably going to have to add 360 because it's negative to make it positive. Okay, and I believe it comes out to 150. So it would be the 30, 60, 90 triangle. Okay. All right, so let's just kind of take a look at what we've got. Okay, what kinds of angles we've worked with. Okay, very first day we worked with the quadrantal angles. Okay, those were your 0, 90, 180, 270. Okay, so there's 4 angles I could ask you about. Yesterday we worked with the 45 and the 30 and the 60. Okay, so we added 3 more angles yesterday. Okay, today we talked about these 3 angles in all the quadrants. Okay, so you can have a 45 in each quadrant. And then you can have the 30 and 60 in each quadrant. All right, so that gives us a total of 16 angles we can do on the unit circle. 3 in each quadrant, and then 1 on each part of the axes. And for each one of these, I could ask you the sine, cosine, tangent, whichever one, we've done them all. Right, so this chart, it's a little confusing because it shows everything at once, but it shows how a lot of things are repeated. All right? If you look at your 45-degree angle, okay, those are the red triangles. That's the root 2 over 2. All the red triangles are root 2 over 2. Okay? Every one of them. The only difference is sometimes they're both negative, both positive, or one negative and one positive. Okay? All the green triangles, those are your 30s. Those are all root 3 over 2, 1/2. All of them. Except sometimes you've got a negative, one negative, or both negative. So really, that is all you need to know. Okay, if you can remember those 3, every other coordinate on this circle is a repeat of those with a negative. That's it. And make sure you know the ones we did the very first day. Those are the ones with the 1s and 0s. But if you can memorize those 3 and the 1 and 0s, that's all you should need to know to do everything with unit circle trig. Yes?
Do we have to memorize like 6 things?
As long as you know the first 3, the other ones are just flipped.
Yeah.
So if you got to know sine is y, cosine is x, tangent's y over x. Yep, you got to know those 3. And then if you flip them, you get the other 3. So I wouldn't even try to memorize the other 3. Just remember, flip them. Yep. Okay, so that's a real good summary of everything we've done. Okay, but in trig, a lot of times we work with angles that are not multiples of 30 or 45. So using the unit circle wouldn't be helpful. Like if I asked, what's the sine of 18? Okay, that's not a multiple of 30 or 45. So we use the calculator. So I'm just going to show you how you type it in. Okay, on your calculator, and everyone's is a little different. We got to look at the angle and see what units we're in. Okay, what unit is this first angle in? Is that radians or degrees? That's degrees. Right, so if you're using a scientific calculator, okay, like, you know what, let me get a picture of it. All right, so if you're using the scientific calculator, okay, the ones that look like this, up at the top they have a button that says DRG. Okay, it's right next to second. Okay, if you press DRG, you'll get a choice of 3 things. Okay, the first one will say degrees, radians, gradients. We don't use gradients. We just use the first 2. So you can just use your arrows to pick whichever one you want and then hit enter. In this case, we want degrees. Okay, if you're using a calculator like this, okay, at home on the computer, the choice for degrees and radians is just that little circle right there. Okay, you just click that. Okay, in this case, I want degrees. If you're using a graphing calculator, is anybody using one? Yep. Okay. So you go to mode, and under mode, you have 2 choices: radians and degrees. Okay, you just highlight the choice you want, press radians or degrees. Even on an older one, it's still pretty much the same thing. If you're using a calculator other than any of those, I'll have to come help you. Okay, every calculator is a little different. Okay. Does anybody have one that I didn't cover and they can't figure out how to change it? You got one? Okay. So what I'm going to do for now, I'm just going to give you one of mine.
Okay.
So you can follow along. Okay, if anybody has one that they're not comfortable with, you can always just use one of mine the day of the test. It'll be what I'm showing up here. All right. So first thing is I'm in degrees. Good. Okay, now I can get out of that. Okay, depending on your calculator, it'll change how you type it in. Okay, on the TI-30s, okay, or a graphing calculator, the way you type it in, hit sine first, then hit 18, and then hit enter. Okay, and you should have gotten 0.309. Okay, how many people got 0.309? Most people? Okay, good. If you're using a computer at home and you happen to use this calculator, does anybody use this one ever? Sometimes? Okay. You got to type it in a little different. Okay. You got to type in the angle first and then press sine. Okay. So you get the same thing, but it's just the order you type it in is different. So on the Windows calculator, type in your angle and then sine. I don't like that because that's kind of backwards from how you read it on paper. Usually we like to type things in just the way you read them. Sine first, then 18. Questions on that one? All right, let's try cosine 356. Okay, what do you get when you type in cosine 356? Yeah, George?
0.9975.
0.9975. Yeah, so let's just say 0.998. We'll round it off. Okay, any questions on that one? Is everybody familiar with that symbol? I should have mentioned that. It means approximately. It's not exactly equal, but we're rounding it. Okay, now before you type that one in, I want you to look at it carefully. What does this one say? Tangent of what? Radians. Okay, there's no little circle on this one. Okay, so when you look at it, you got to say, wait a minute, he's giving me a problem. He didn't put the circle. 2 2.4 is in radians. So now I got to change my mode to radians. That's the easiest way to do it. Just put your calculator in radians. If you want, you could take 2.4 and change it to degrees yourself. I wouldn't, because anything you do by hand, you could make another mistake. Just put the calculator in radians and it'll do all the work. So I'm going to go to mode, go to radians, and I'm going to get tangent 2.4. Okay, anybody get negative 0.916? Okay, good. Did anybody get, let me type it in like this. Did anybody get 0.042? Okay, if you did, it's because you were in degrees. Okay, so negative 0.916, that's correct. All right, so those are the three that we have buttons for: sine, cosine, tangent. What about if I gave you this one? Cosecant of 247. Okay, it's not a multiple of 30, it's not a multiple of 45, so we can't use unit circle trig. So we got to use the calculator somehow. Anybody know how we could do that one? Yeah?
You could press the second and then press sign.
So press the second and then the sign, that -1 thing. All right, so that's a good guess. And this sign with the -1 is very important, but it's actually something we're not going to use till next week. It won't help us here. But that's good guess, and it's very important, just not for this. Anybody have another guess how we can do cosecant? Think about how we've been doing it all week. So which trig function did we flip to get cosecant? And that's the idea we're going to use here. Yeah. All right. So what I want you to do is start by finding the sine of 247. Okay. And now take that answer and flip it. Okay. Do 1 divided by. Now type that answer in. Negative 0.9205. That's enough. All right, so we're just taking that answer and flipping it. Negative 1.086. So it's exactly what we've been doing all week. Take what you got for the sine and flip it. Okay, how about the secant? What trig function would we use to find secant? Cosine. So what I can do is I can actually type it in all in one step. Let the calculator flip it for me. Just type in 1 divided by. And now what would I put in the bottom? Cosine of 6. So what this is going to do is find the cosine of 6 and flip it all in one step. If you don't want to do it that way, find the cosine of 6 first, and then type it in, flip it yourself. Okay, but you should get about, whoops, I made a mistake. I didn't switch back to radians. Okay, I'm still in degrees. Did everyone see the mistake I made?
Yeah.
Okay. I typed everything in right, I was just in the wrong mode. Okay, so just type it in again. Now we're good. Okay. 1.041. Yeah.
We just have one, so.
Yeah, well, this is our last one.
Oh.
Okay, and the last one, cotangent of 13. Okay, looking at it right away, it's in degrees. I'm going to change the mode right away before I forget. Okay, and anybody tell me, how would I type in cotangent of 13? Yep.
1 divided by tangent of 13.
Yep, take the tangent and flip it. So you should get about 4.331. Okay, so the last 5 or 6 questions on the test, they'll all be calculated. Okay, so make sure you specifically know how to do the secant, cosecant, and cotangent. So the homework tonight is on 116. It's 49 to 57 odd and 67 to 81 all. You will need a calculator for 67 to 81. Okay, remember, for the test tomorrow, just a calculator, no reference sheet. And you've got about 25 minutes. Okay, so please start that, and if you finish it, I'll look at it, and then there's no other homework tonight.